Well, good morning, good afternoon, and good evening to all participants from around the world. It's my great honor as the president of the Institute of Civil Engineers of Costa Rica to welcome you to this important webinar organized by the World Council of Civil Engineers. Today, we gather to discuss one of the most pressing challenges of our time, climate change and its impact on engineering. As civil engineers, we are at the forefront of building resilient and sustainable infrastructure. Climate change is no longer a distant concern. It is a reality affecting our cities, communities, and the very foundations of our profession. This moment calls for innovative solutions, collaborative efforts, and a commitment to engineering that prioritize both progress and sustainability. It's an honor to have engineer Rene Castro Salazar as our speaker today, bringing his expertise and insights on how we, as engineers, can adapt, mitigate, and lead the way in addressing these challenges. Engineer Castro is a Costa Rican civil engineer. He has had several public positions. He was Minister of Environment, Energy, and Telecommunications until May 2014. He is a civil engineer from the University of Costa Rica. He also obtained his doctorate, his PhD, and master degree from Harvard University. His postgraduate studies focus on design, environmental economics, and natural resources. I encourage you to actively participate, share your perspectives, and take this opportunity to connect, learn, and inspire action in our respective fields. Thank you for being here, and let's make this session a valuable discussion for the future of our profession. Welcome, and let's begin.
Thank you very much, Daniel, our president of the Civil Engineers Association of Costa Rica. Allow me to share with you a presentation that I prepared for this meeting. This is a presentation that I did to the board of the Civil Engineering Association and the Costa Rican Federation of Engineers. Let me only make sure that it's shared. Can you see it?
Yes, we are seeing your.
Okay.
Yeah.
First of all, let me do a brief summary of what the situation of climate change in the world is. This graphic shows a red line going all the way to a warming potential between 3.5 and 5.3 Celsius for emissions exceeding 30 gigatons of CO2 per year. And this has been the business as usual scenario with some efficiencies closer to the year 2100. The second line, the green one, is what the scientists have been recommending us in order to not exceed 10 gigatons of CO2 per year, assuming that by 2100, there will be 10 billion people in the world. This means 1 ton per capita per year. As an example, one vehicle in any of the countries of the Americas usually will emit around 2.5 tons of CO2 per year. So only the use of the vehicle will exceed what the scientists are recommending to be the stabilizing line and the warming impact between 0.9 and 2.3 Celsius. And unfortunately, what is happening is closer to the red line than to the green line. And the Paris Agreement in between, but as we all know, it's not really advancing too much. The second graph shows a tropical storm path from 1851 to 2017 in the Caribbean and the Atlantic, and from 1949 to 2017 in the Pacific. Every line is a path, a real one. As you can see, the intensity and frequency are increasing dramatically, and the scientists are forecasting that this trend will continue upward. And then the ice melting, especially in the North Pole, can suggest you why, the discussion about, Greenland and the discussion of the international maritime traffic options in the Northern Hemisphere has become relevant again. And you can see in the orange line the changes from as 50 years ago to more recent photograph, and obviously it has an impact on the sea rise. And finally, for this introduction, this is a report from the NOAA since 1880 to 2021 about the temperature changes. The blue ones meaning a reduction in temperature, especially in the first years of the Industrial Revolution, and then a steep increase and some period in the center around 1940 and 1960 with ups and downs depending on volcano eruptions and other natural disasters that had an umbrella impact on the world on those years. But in general, the trend is upward looking, and as is measured, is not only forecasted or made out of the estimates. Then we are witnessing in several countries. I collected few ones from my personal experience in the Americas. This is Cuba, already suffering water scarcity and problems of energy supply, part of it due to old infrastructure, but part of it to severe changes in the pattern and in the traditional rainfall. And then the other extreme, Uruguay and Costa Rica, my country, they usually compete to be number 1 or 2 in the best indicators in terms of well-being and public services to citizens. And I was in Uruguay in 2023 when they have to adopt a very stringent program of supplying only saline water because they were suffering a severe drought, and they had to transfer the cows and the animals to different locations rather than the main center of the country. And they have to recommend to the people to drink bottled water and to use the salted one for everything else. And then a big surprise in Chile. I was there, and strong winds exceeding 120 kilometers per hour, whereas the engineering design for most cities in Latin America, it has a limit of 80 kilometers per hour. It provoked, disruptions, brownouts, blackouts in the electricity of all the cities, including Santiago de Chile, regardless of a modernized transmitting and distribution electric system. It took the city of Santiago about 4 or 5 days to restore the electricity to 1,065,000 people. And this is exacerbated already 2-3 weeks ago. Already the electricity service was interrupted. Even international flights were canceled. And this is becoming the norm rather than the exception. And then the forest fires, the wildfires, only in Brazil last year, they lost about 300 square kilometers, 300,000 square kilometers, 6 times the size of my country, Costa Rica, due to forest fires. And most of the forest fires are related to vandalism and poaching, illegal poaching, and also to malpractice in agriculture. But the warming seasons are exacerbating the potential of forest fires in all the Americas, not only in the tropics, as was the case in California this year, and in Canada, and in several other countries around the world. And then, of course, as I mentioned at the beginning, the sea level is rising in Central America. You can see here pictures from Nicaragua, Guatemala, and Costa Rica, and other regions that are forcing us even to redesign, to very high maintenance costs in the coast road system, and also in protecting the harbors and the systems of export-import of food in Central America and in the Caribbean. And just to show again some statistics, 3.6 millimeters per year is the sea rising, a little bit higher in the Caribbean than in the Pacific, but we are suffering a dramatic change that is affecting also the energy reservoirs, like the hydropower systems of Central America and the water supply. For example, Costa Rica has been producing close to 100% of energy from renewable sources, mainly hydro. And last year, we have to announce that there was very likely to be a rationing period or blackouts, especially in the month of March and April, due to low level of the hydro and the water reservoirs in the country. And this is the more and more the common pattern in the Americas. And another factor is the heat level. As you may remember, there are 4 levels describing the heat level. The first one is with some possible physical fatigue. The yellow one, possible heat stroke, cramps, exhaustion. The third one, the orange, prolonged exposure may even cause physical problems, and the red one, high probability of heat stroke and other health problems. Is this theoretical? Why the countries of the regions are defining and paying attention to the heat level? Well, let me show you a situation in the harbors of Central America. This is in the Pacific. Central America, for example, in 2022, we oscillated between 33 degrees to 35. And in the Caribbean, in the month of July, between 31 and 33, and in Dominican Republic, in the same period, between 34 and 35 in the reddish area, forcing the countries to stop working outdoor, to reduce the number of hours of outdoor working. For example, in some of the harbors, you have to introduce now air conditioning systems. You need to reduce the use of the service to the cargo ships and to providing water to the passenger and the cargo ships, and it's becoming an increased number of days of inactivity, including in the Panama Canal, that also increase the cost of the export of products and the import of food and other basic materials. And let me give you a brief example of what can you do in the harbors to adapt to climate change. And now I'm going to be talking a little bit of how you adapt, how you introduce that in the engineering practices, how you change your engineering practices to be better prepared, to reduce the cost, the economic cost, and to reduce the losses of human lives that are currently increasing. Typically, in a harbor, you study the currents, the wave height, the beach dynamics, the sediment transport, the agitation of docking stations, the drainage system, the energy supply, the water supply, the precipitation, the wind, the temperature, and especially relevant in a harbor is the waiting time or the crane movement, and that provides a measurement of the efficiency of a harbor and the cost. And for example, in Costa Rica, we have been reinforcing in the Pacific some of the coastal infrastructure just to keep the water under control. It is extremely costly, in the neighborhood of $50,000 per lineal meter or more. And this is going to be the norm and not any more, a preventive investment. For example, to keep the channels clean and the maneuvering area useful, it costs up between $8 and $11 per cubic meter, plus the mobilization of the equipment and the demobilization of the equipment. And this is also becoming the norm in the harbors and in the Panama Canal in the region. Flood controls, for example, in Limon, in the Caribbean, in Costa Rica, we invested $18.5 million in 2019, and in Tijuana and Rosarito in southern Mexico, the cost it was between $11,000 to $16,000 per kilometer for pipes diameter between 20 and 38 centimeters. And it's becoming obligatory to invest in drainage and flood control in all the harbors and several other of the transportation infrastructure. For example, international airports and the main, the national and municipal roads in all these countries. And sometimes there are solutions, that combine the natural and engineering design, and we have been doing some of this in the manglars and in the reefs and the blue areas, but the demand will increase sharply of preventive and adaptive possibilities of the infrastructure. So we propose to the College of Engineers of Costa Rica to develop a code for adaptation to global climate change. Based on this idea, 50 years ago, the engineers developed the Costa Rican Seismic Code. That code forced the country and several others in the region to adapt buildings, to adapt infrastructure, to change the way we design. For example, it is no longer advisable to have swimming pools in the last floor of the hotels in order to reduce the seismic impacts. And 50 years later, we know that the benefit, the economic benefit, and the lives saved is being extremely relevant. This is a picture of the railroad damage in Costa Rica from one of the last earthquakes and seismic situations in Costa Rica that shows the economic impact of the infrastructure that is not being adapted. So we have now an ongoing project of the Costa Rican engineers with the Ministry of the Environment and Energy and the Green Climate Fund that will work in 3 levels: at the family level, at the municipal level, and at the national level. And the proposal was approved on March 11, 2024. It is the money coming from both the Green Climate Fund, about $1 million initial investment, and the engineering college, another important sources. Probably when the process of consultation and discussion and methodology assessment is finished, we will need, of course, to increase the investment in the design and in the explanation to the public, and eventually in a process in the National Congress to have a law regulating the infrastructure development, the construction codes, the public investment in roads and harbors and everything to the new situation will require a much larger investment. But as happened with the seismic code, preventive investment is usually 1/10 or more the reconstruction investment of the natural disasters. And just to give you an example, we personally estimated that if in Costa Rica we adapt the housing to the new climate conditions, for example, introducing systems of weather management, windows, reducing the heat, systems of coloring the roof, and, for example, with white in order to increase the albedo, will cost us about $50 per square meter. And if we want to do something else for managing the gardens and the tree planting, may increase the cost to $100 per square meter. But this will be alternative to what is happening. That is a small country like Costa Rica importing 250,000 new air conditioning systems every year with a cost of about $70 million per year. And naturally, this is possible in the higher income classes and in the newest infrastructure and the schools, the higher schools, the hospitals, the basic housing solution, and is not ready, is not receiving the adaptation, and is becoming affected by the increasing heat and the unhealthy situations that damage also the productivity, and in the case of the students, the ability to learn with extreme heat. And another example, this time at the municipal level, is using all the recovery information from past natural disasters located geographically and helping the municipalities and the households to know if there is an imminent risk close to the family house or to the new municipality infrastructure or to the neighborhoods. And for example, we can now identify the potential for droughts, for extreme rainfall events, river flows, avalanche, increased number of pests and diseases from the last year's data, and provide the users with information to the level of the plot, to the level of the property of the family in a particular location. This is a very remote area in the northern part of Costa Rica, closer to the Guanacaste National Park. And to give you an example, in this particular plot, we run all the data from the public emergency systems in the country and universities and others, and found that for this particular plot, for example, there is no risk for slopes. There is a risk from rivers close to it, and very high risk for volcanic activity near that particular plot. This is available in 26 municipalities already in the country. It's not open to the public yet. We hope that the Engineers Association will work with the municipalities to provide the people with the information before investing in the new house or in a new shopping facility or new road. And then we will be using the money more to prevent and to reduce the impact of the climate change than to reconstruct that has been the norm in the last few years. Hopefully, with the code for adaptation, we will be able to offer this not only in the 26 municipalities that we have today, but in 100% of the municipalities in the country. And eventually, this will become a law, and then information to the general public and to investors will be deeper and wider and more available to individuals doing investments or to the municipalities keeping the resources healthy and useful. And then a final example, I presented the wildfires in Brazil, and this is the similar wildfire image from the website of FIRMS, the Fire Information for Resource Management System, that is available 24/7. And this shows you how northern Central America is on fire, and something slightly different is happening in Costa Rica. Why is that? If it's similar locations, similar latitude, similar culture, language, economic conditions. Well, because in Costa Rica, there has been a investment in prevention and culture and education since the 1996, when we changed the forest law in the country, and we also introduced in the agricultural code sanctions for malpractice in agriculture. For example, after the sugarcane harvest, you can no longer, just destroy the waste or fire the waste and then ignore the consequences in the neighboring properties and in the neighboring forests. So we have now a large number of forest fire fighters, about 1,100 volunteers trained and equipped. Some of them work at the university, some of them in private companies all over the country. In March and April, they are really, really busy in Costa Rica. But then in August, as you can see in this picture, they go volunteering to Canada on other countries, supporting in a developed country, with a South-North cooperation in the month where the forest fires are at the peak. In the northern part of the continent is in August, and as I said, in Costa Rica is in March and April. So we can cooperate and help each other instead of duplicating the investment, the equipment, and the people working in this. And we hope that the Costa Rican Code and the cooperation between Costa Rica and Canada will inspire others to expand these preventive efforts in forest fires and other adaptive responses to the climate change. This is my presentation for today. I'll be happy to answer any question if there is one. Thank you very much.
Well, thank you very much for your presentation. I got so many questions on my WhatsApp, so I'm going to start with the first one, and it's regarding rain. You were talking that the quantity of rain that we have now, it's more than that we have in the past, and how we can take into account that in the new climate change code. Because as we were talking before, for instance, now we have new phenomena related with rain. For instance, we have pounding in our shelters, and also that we have to update our maps regarding rain and all these kind of things. Because actually now in our seismic code that we are going to have here in Costa Rica, there is an update that now we have to take into account the rain load, and that's new actually in our new seismic code.
Well, probably I should clarify that is less the amount of rain, the annual amount of rain that has changed, is more the seasonality of it, is more the places where it is located. So we have problems that, for example, the reservoirs built to collect the water are no longer receiving all the traditional quantities of water. And we have problems that the natural systems of drainage, for example, they work well for X amount of rain in a day or two. And sometimes the same amount will now be in 2 or 3 hours. So the natural drainage system is not properly working. And we are seeing this in the cities, and we will need to invest more, both in analysis and in the design and in the drainage systems in the infrastructure and in the cities. And we have not enough data yet, but it is becoming more and more evident, and modeling will be necessary.
Perfect. The second question is regarding wind. When you show the map and you show the path of all the hurricanes that we have now in America, it seems that we need to update as well our codes. For instance, here in Costa Rica, we have the experience that then when we update the speed of design for wind, we have to increase it. But how we can continue like measuring that, because it seems that now we are going to have more and more hurricanes hitting our coast. So it's a question more related that how we can follow that. And if you think that it is related with climate change, that for sure it is. So.
It is. In the case of Costa Rica and Panama, we are blessed that few hurricanes hit us directly. We usually suffer more of the tail of the indirect possibilities, but in the other countries, this is becoming more frequent, and the design wind used to be 80 kilometers per hour, and now is more frequent to see speeds of 100, 120, as I mentioned in Chile, we will need to change the design factor. But in addition to that, we will need to change what we consider was good for gardening and for public parks, because the ornamental trees, in the case of Chile, were responsible to damage the transmission and distribution lines, because they couldn't resist those winds and they fall apart. And I have seen in countries like South Korea and others that when there is the hurricane season, they reinforce with wind lines and wind supports the trees individually. So we will need to change our practice and to introduce some seasonality on the way we plan our gardens and parks. But in addition to that, we will need to change the design factors in the infrastructure or in other systems. For example, the public advertisement in the roads system. They are really suffering now. The wind blows.
Perfect. And the last one is related with the climate change code. How is going to be the path for that one? Because we have to work together. So now we are working with engineers and architects, but let's talk about some other professions that could help us on this effort.
Please notice that what I suggested and presented here was a code for adaptation of climate change. So it's not including the pure mitigation possibilities. Of course, some possibilities like the drainage or the use of energy in renewables, they have both impacts on adaptation and on mitigation, but we're focusing on adaptation. Yes, we will need to incorporate, for example, the agronomic engineers. I visited Barbados recently, and in my mind, it was extremely important to pay attention to the electric grid and to the road system. And then I noticed that they were not that concerned about that. They thought they had enough engineering power to redesign, that they might eventually will need to use it under earth, the ground system instead of the traditional transmission lines. That is more costly than the other one. But to my surprise, that was not the main concern. The main concern for them was food supply, because they became unable to produce their own food. They have to import almost 100% of it from Miami and other ports. And so they were concerned that the hurricane system will interrupt the maritime transportation, and so they will not get enough food to satisfy their population in the weeks following a hurricane or something like that. So agronomic engineers is definitely one additional expertise that we will need. Another one will be the health professionals. With longer drought periods, and then with the changes in the rainfall, that is very likely that we will have 2 seasons of mosquito growing. And mosquitoes, they usually are vectors for dengue fever, for Nile, and for chikungunya and other illnesses. And if you have 2 seasons per year, so you can imagine the impact on the health indicators. And as we know in Costa Rica, for this kind of mosquito control, we will need to improve the draining system, and we need to reduce the from the potholes to the water used for swimming pools, for irrigation, etc., etc. So the health professionals will need to be incorporated rather sooner than later.
Excellent. We have another question in our chat, and is Engineer Bolaños. So the question is, for the adaptation code, it's imperative to have data and good climate projects. As long as I understand, the forecast that IPCC gives, lately they indicated that the certainty was no longer precise. The projections presented with all changes regarding emission no longer are identified within the B1, B2, A1, A2 scenarios. Could you elaborate a little about that? Or do you know something about this?
When I was a student and we designed the hydro projections, for example, at that time we used the data from the last century, the data collected from the last century, and then we model it for the years of the reservoir or the dam or the investment that we were planning. And at that time, we use a factor of plus minus 20% of the historic data. I have seen recent studies of hydroelectric facilities that, first of all, can no longer use the historic data with confidence because the variation now seems to be plus minus 50%, 50. And so it's changing the whole design practice. It will require from us, more modeling, more assessment of alternatives. It will require, for example, that countries like Costa Rica, instead of rely on hydroelectricity, will need to use other renewables, like biomass from agriculture, for example, that is available in March or April when we have the dry seasons. It is possible now to use agricultural waste to produce energy. So this will be some of the changes that we may need. And then, another possibility is how to recover the rainwater better. In countries like the tropical ones that we are water rich, there is a tendency of overuse of water because, nobody really is used to scarcity. But scarcity will become the norm in the dry month, and then flooding will become the norm in the other month. So we will need to change our way of thinking, and I hope that, yes, collecting better data, doing some engineering thesis, doing and sharing more information about the professional associations in the continent, we may be able to reduce the impact of the climate change. Not to eliminate it, but to reduce the impact in economic terms and in life terms.
Perfect. Well, thank you very much for your presentation. We learned a lot of adaptation and all these kind of things regarding climate change, and hope to see you in a near future in another webinar. Thank you very much again. And to all the audience, thank you very much for your attendance.
Thank you. My pleasure. Have a good day.
Have a good day. Bye-bye.